Octavio Mateus, researcher at Universidade Nova de Lisboa and Museum of Lourinhã in Portugal. The Mesozoic of Portugal is very rich in vertebrates. We have late Jurassic dinosaurs, we have Cretaceous tracks, late Jurassic mammals, but the Triassic was fairly unknown until now. This is probably the best bone bed in all Mesozoic of Portugal. In this spot we find hundreds of bones. We have at least 10 individuals, counting by the number of skull parts. It is fairly unique. It is fairly good for studying and understanding the kind of fauna we have here. Moreover, we find not only temnospondyls, but we find phytosaurs and probably other archosaurs. The potential is great. If there is one spot where you can find the first dinosaurs from Portugal and the first dinosaurs from Europe, it would be here. That's one of the best spots to find them. We have several locations, several layers with bones. This is definitely one of the best in Portugal.
I'm Steve Brusati. I'm a PhD student at Columbia University in the American Museum of Natural History in New York. We're here digging at this bone bed because we're interested in the Triassic period. This was a period of time from about 250 to 200 million years ago, and the Triassic was a very interesting and important period of time. This is when dinosaurs originated, as well as many other groups like mammals and turtles and crocodiles. And the Triassic also ended with one of the largest mass extinctions in the history of the planet. So that extinction happened at the end of the Triassic. This bone bed seems to be very close to the end of the Triassic. So it's one of the few good sites where we can actually see what kind of animals were living at this time and maybe understand a little bit about this extinction. Was it fast? Was it slow? What caused it?
My name is Richard Butler. I'm a paleontologist at the Bavarian State Collection for Paleontology in Munich, Germany. In early 2009, myself, Steve Brusati and Octavio Mateus started talking about a paper we'd seen which described some very fragmentary amphibian fossil remains from this general area. And we were very excited about this paper for a couple of reasons. First, we had no idea that there was the possibility to get Triassic vertebrate fossils from southern Portugal. And secondly, it seemed that these vertebrate fossils were very close to the end of the Triassic, to the extinction event which we have at the boundary between the Triassic and Jurassic periods. So we came here in the summer of 2009 to prospect and to search for vertebrate fossils, and that's when we first found this bone bed, and that's really where the project got started.
Hi, I'm Sebastian Steyer, paleontologist at the National History Museum of Paris on the CNRS. The animals discovered here are very impressive because they were giant salamanders of around 3 meters in length, carnivorous and aquatic, and we found pretty nice skeletons, almost complete, of different individuals. So we are starting to have a good reconstruction of the environments as well. And these animals are very important because they will make the link between what we know in the north part of Pangaea at that time, 210 million years ago, and what we already discovered in the south, like in Morocco. So Portugal is very important for us because it makes the links between north and south of this global Pangaea.
I'm José Carlos Colbert. I belong to the New University of Lisbon, the Department of Earth Sciences. I'm collaborating with this team in the area of the tectonics and the structural analysis of the evolution of the first stages of the Algarve Basin.
My name is Francisco Lopes. I am a teacher of biology and geology at the secondary school of Albufeira. Our work is to understand better the sedimentary environment conditions and climatic conditions of the constricted period between the Triassic, probably Middle Triassic, and the base of the Lower Jurassic. For example, we have here in these outcrop rocks that without any doubt we have both of these rocks the first volcanic rocks associated to the camp, and below of these rocks we have the bone beds with fragments of stegocephals that the rest of the team are working at this moment. This project, it is very important, in my opinion, to understand better and to know the geologic and biologic story of this period of time.
I'm Jessica Whiteside. I'm an assistant professor of geological sciences at Brown University in Providence, Rhode Island. We're here to study the environmental changes that happened about 200 million years ago, leading up to and covering a mass extinction event at the Triassic and Jurassic periods. We're here reconstructing paleoenvironmental change.
I'm Alex Kasprak. I'm a PhD student at Brown University in Providence, Rhode Island. And I'm interested in studying environmental change in the geologic record, especially those times associated with significant mass extinction, which is why it's great that I get the opportunity to work here in the Algarve Basin, as it preserves sediments that record the environmental change associated with the end Triassic mass extinction, one of the 5 largest mass extinctions in the history of life on this planet. So what I'm doing here is sort of twofold. First, I'm just assessing and understanding the basic geology of the region, so that when we go to make interpretations about environmental change, we can first sort of pin that in a clear understanding of the geology. So, for example, here I work with the paleontologist in this bone bed, sort of trying to understand where within the specific geology these fossils are coming from. And the second thing that I do is to collect a lot of rocks from this basin in order to extract fossil chemicals from them, so I can perform a series of analyses on these rocks to infer environmental change in the past. And that's great working with paleontologists, because I can look at the actual real fossils that are there and couple that with chemical fossils and understand really what was happening at this significant time in Earth's history.
My name is Gustav Hendricks. I'm a PhD student at the New University of Lisbon, and I work on non-avian theropods, the meat-eating dinosaurs. Working in this field is truly important for me as a PhD student, as it gives me first some field experience. That's extremely important as a paleontologist, as part of the work consists of digging on some site and discover new fossils. And this is the case here in this site. The second thing is that here this site gives some early amphibians. So as a PhD student working on theropod dinosaurs, I know not many things about those animals. So it gave me new knowledge about these animals, the ancestors of these amphibians or living frogs, toads, and this is very important for me.
I'm Emmanuel Chop, and I'm a PhD student of the Universidad Nord-Lisboa, working on dinosaurs. The difficulties of digging in this quarry is that the sediment where the bones are in, it's very crumbly, so it's very difficult to take the bones as an entire piece. And there are so many bones that you practically cannot take one bone by itself, so you have to take blocks. And we cannot take huge blocks, so it's difficult to divide it into parts.
I am João Marinheiro, and I am a collaborator of the Museum of Lourinhã in Portugal. So right now we are digging a trench around this newly found skull, which might be isolated, which is very important because it's one of the few isolated skulls we have found so far. So we are clearing the site, we are going to dig around it so we can put some plaster on and just release the block as a whole, so we can just take it. Also, here is a limb bone that we found yesterday. That might be a tibia or a radius, and that's almost complete.
flattened this way.
Flattened
Not
a
exactly
little
like
bit,
this,
yeah.
but a bit like
Yeah,
this.
yeah, yeah.
That's what I think it is.
The curvature is typical for Metoposaurian, this curvature.
So
it is fitting with